Hey, ready? So we are going to be talking about operating with radicals. So operating with radicals, adding, subtracting, multiplying, dividing. Each of them, they don't necessarily have their own rule, but it's different than what we're used to and yet similar all at the same time. So we're going to take it easy and we're going to start with adding and subtracting first. So here are the steps to adding and subtracting. When you're adding and subtracting, you always need to simplify all your radicals first. Okay? You need to identify the radicals with the same index, meaning that say they're all square roots, those are the ones you're going to combine. You would not combine a square root with the cube root. That's got a 3 on it as the index. Okay? The radicand, if I've got the square root of 2 and the square root of 3, these would not be combined. That's kind of like me saying that x plus y is, I don't know, xy. I can't do that. So, your insides have to match. If you need to write that, you can. Insides and roots must match. For common radicals, I want you to add or subtract the coefficients and then keep the common radical. So this step right here is kind of like when we're combining like terms. I'm going to abbreviate it as CLT, combine like terms. So this is kind of like 3x plus 2x. That's going to give you 5x. Or you've got 7x minus 4x. That's going to give you 3x. Similarly, all you have to do differently is just make sure you remember that if there are radicals there, you keep the insides that are the same and you only combine those. So let's try both of these out. We've got a subtraction one and an adding one. The try it with a partner. You are going to be responsible for doing those, and then you're going to be putting those answers in online. I'll be telling you how I would like for you to put it in if we're using Canvas. If we're not using Canvas or using something like Go Formative or something like that, then I'll tell you how to do that as well. All right, so the first one we're going to do is negative 2 square root of 20 minus 2 square root 5. Okay, well, this one is already simplified because 5 is a prime number. So we need to try to get this 20 and see if we can get it to a common radicand, common insides with 5. And we know 20 is not simplified yet. So if you need to do your tree, you are more than welcome to. It's 4 and 5. Circle that. It's 2 and 2. Remember, couples go out and my singles stay in. So this becomes 2 square root of 5. Well, don't forget we had negative 2 already times whatever the square root of 20 was, which is 2 square root of 5. And you copy everything else down. So all we've changed is this, and we're substituting because the square root of 20 is equal to 2 square root of 5. They're equivalent. All right, now remember, outside times outside, and well, there's no inside times inside here, so it just stays the same. So you have negative 4 minus 2, which is just negative 6. And don't forget your radical and your radicand of 5. And this would be your answer. Once you get your radical simplified, you just treat it as negative 4x minus 2x. You treat your radical as a variable. Your variable is not going to be affected when you're adding or subtracting. So let's try another one. We've got 10 square root of 7 plus 2 square root of 63. So again, this one is already simplified because 7 is a prime number. square root of 63. I'm going to use the perfect square method this time because I know that the square root of 63 is the same thing as the square root of 9 times 7. Well, couples go out, and 9 would be 3 times 3. That's 3 square root 7. Here it is broken down a little bit so you can see. And sorry, if you hear pitter patter and lots of noises near the mic, that is Ash coming to lick me. I'm sorry. She loves giving kisses. All right. Stop. So this becomes 3 square root of 7 for the square root of 63. So we're going to rewrite everything we have. And we're going to plug that 3 square root of 7 in. And now, outside times outside, and inside times inside. So this becomes 6 square root of 7 now. Okay, when we add our like terms, because they have the same insides, then we're going to get 16 square root 7 as our final answer. And that's it. Now, these, you have a couple more. Okay, I want you to try them out and see if you get them right. Okay. Now, on the you try, I will help you out. I'll help you get started with it. On this one, you're going to have a few that need to be combined. And they're all simplified because we know that from the Radicands. They're all prime numbers. It's a prime number and they don't have any doubles in it. If these numbers were not prime, we would see if they had any doubles. For example, if it had square root of 10, we know that it has 2 prime numbers, but no couples, so we would leave it as such. Okay, so in this one, we've got 2 square root of 7 plus 4 square root of 7 plus 3 square root of 7. So all of those would be considered like terms. So 2 plus 4 plus 3, that gets you 6 plus 3, which is 9 square root of 7. Then you've got your square root of 3. Oh, that's the only one. So we've got plus 5 square root of 3. And then finally, we've got negative 5, negative square root 5, negative square root 5, negative 2 square root of 5. So remember, this means this is a negative 1 square root of 5, negative 1 square root of 5. So 1 plus 2 gets you 4. And since we're subtracting all of them, it's going to be negative 4 square root 5. Okay? So it might look longer and you're like, I don't know how to do this. Your insides got to match. All right? And that's how easy it is to add and subtract radicals. Now, this next one, you kind of already know how to do, and we've been doing it since we first started simplifying radicals. All right, we are going to go ahead and multiply your coefficients, and you're going to multiply the radicands, meaning the insides, using that product rule, meaning A times B is equal to AB. Pretty much what this is outside times outside and inside times inside. This is what we wrote on our notes the first time, because technically multiplying, yes, it's an operator, but it's something you already know how to do. Now, in the ones we've been working with, they're simpler. They're simpler types of problems. Okay? This part puts all 2 steps together, which is why I keep repeating outside times outside and inside times inside. Wonder if that's important. Your final step, though, is going to be you're going to have to simplify that resulting radical. Once we've got radicals times radicals and whatnot, it kind of creates bigger radicals. So let me show you what I'm talking about. All right, we've got the square root of 8 times negative 3 square root of 2. If you want to put parentheses around there so it helps you, you can. All right, square root of 8 is 2 square root of 2. So let's rewrite that part. Now remember, outside times outside. So 2 times negative 3 gets you negative 6. And inside times inside. 2 times 2 is 4. Well, wait, the square root of 4 is 2. So we can simplify it and go negative 6 times 2, which gets you negative 12. And that would be your simplified version of that radical. If you're like, wait, how did you do that? Remember, we did negative 6 times the square root, okay, because that was 2 times negative 3. And your inside times inside was 2 times 2. And sometimes it might be easier for you to keep it like that, so that way you have all your factors to begin with. But notice now we've got a couple. And couples go out, singles stay in. That there was only a couple inside the house, they went out, house is just full of ones. That's it. The one is always there, kind of like air. All right, so now let's try this one. This one you're having to distribute. So, distribute it out. And you're still going to do outside times outside and inside times inside. Let me show you. Once I get my colors figured out. Got some UTA colors going right now. So we've got square root of 6 times 3. It looks like this. Technically, you don't write it like that to be polite, and because it can be confusing. If you write it like 3 times the square root of 6, that is less confusing because we know for a fact that the 3 is on the outside. This one, it could be construed as the 3 is inside or under the radical and part of the radicand. So you got to write your coefficients, your integers on the outside. Plus the square root of 6 times the square root of 8. Because this is inside times inside happening on this one already. We look at this, not a prime number, but its only factors are 2 prime numbers and they're not couples. So we leave it as such. Okay, so we've got 3 square root of 6 plus the square root of 6 times 8. So we need to simplify that one. We know it's 48, by the way, 6 times 8. Neither of these are prime. We do get some prime numbers out of them. And you might want to recall that this was actually the first example that we did in our simplifying radical notes. And we know that this becomes 4 square root of 3 because you have one pair of 2's, another pair of 2's, and then singles stay in. So we've got 4 square root of 3, and that's being added to 3 square root of 6. Their insides do not match. This would be your final answer right here. All right. Now, if you are writing this online or typing in your answers online, for example, on something like Go Formative, that one you just have to open the keyboard button and it'll give you the option to type it in with the radical. Do not go searching for the square root symbol and type that in and copy and paste. You will get it wrong. If you are not on Go Formative, say you're ever on Canvas, for 3 square root of 6, the way that I would type that out would be 3 square root 6. No spaces. 3 square root 6. And this whole thing would be how you would type that out. Obviously, you would have this as well for our answer, but that's okay. Now, you might be tempted to use calculator, but most of these questions are going to be open-ended. If you get a multiple choice question, don't be tempted to use the calculator. You're not going to get to use that on your SAT or in geometry to do things like this. All right. Now, I am going to give you a mega problem here. Nah, you know what? I'll let you guys have it because next we have to do division. And that one's going to need some brain power. Okay? I want you to break apart the radicands using the quotient rule. Pretty much what that means is it's the square root of A over the square root of B. We share the radical. We share the love. So we're going to share the radical love. I want you to look for perfect squares and simplify those first. Okay, it's easy, right? Simplify any radicands if possible. And then simplify again along with any coefficients. So we're going to start off with something easy. We've got the square root of 8. Let me write over it so we can see it better. The square root of 8 over 32. So, we've got applying that that quotient rule and putting each of those inside a radical. Okay, well now, there are two ways you can do this. Okay, some of you might already see one way, and that's okay. And you're like, I don't know, I can't see it. So if you can do square root of 8 over square root of 8 times square root of 4, you can 1 that out, and you're left with 1 over the square root of 4. And then you simplify that square root of 4. Or, we do what we know best and simplify. We know the square root of 8, since we've already simplified it, would get us 2 square root of 2. Alright? Now the square root of 32, I'm going to use a perfect square method. And I know that it's 16 times 2, so therefore it's just 4 square root of 2. So check this out now, and this becomes easier. These won out because the square root of 2 divided by the square root of 2. Your insides match and you have the same index, you can 1 them out. So you're left with 2 over 4. Well, that's the same thing as 1/2. Okay, so now, I know this says the U try, but I'm going to do it with you anyways. Alright, so this is the square root of 8 over 98. For 8, we know it's going to be 2 square root of 2. But with the square root of 98, it's going to be 7 square root 2. Because I know that it's square root of 49 times the square root of 2. And that square root of 49 is just 7. Knowing those perfect squares will help you become so much faster at this and at your math in geometry, in algebra 2, and so forth in general. It helps you pick up speed on your SAT too. So you get 2 square root of 2 all over 7 square root 2. This one's out, and you get 2 over 7. That's it, because 2 over 7 can't simplify. And say if you were left with something like this instead, you would just simplify your constants, your coefficients that are on the outside. You don't need to draw that 1 in there, so just be the square root of 2 over 2 square root of 3. But there's a problem with something like this. We don't like that radical stuff on a denominator. We don't like it on the bottom. So if it can't be simplified and the radical can't be removed, like it was here and here. Then we do something called rationalizing the denominator. So pretty much, to be fully simplified means there is no radical left in the denominator. This can happen when you're dividing. So when you're eliminating that denominator, it's called rationalizing. This is something you're going to need huge in geometry and algebra 2. In order for you to rationalize a denominator, you're going to multiply both the numerator and the denominator by the radical that's in the denominator, and then simplify. So let me show you with both of these. Say you've got something like this. I've got a radical in the bottom. I can't have that. So I need to multiply it by itself so that the square roots cancel out on the bottom. But what I do to one, I have to do to the other, because I can't just multiply all willy-nilly because I feel like it. In math, there has to be a reason. The square root of 7 over the square root of 7 is just 1. So I'm technically cheating and saying I'm multiplying by 1. That's all math is. Can you find the loophole? So we get 4 square root of 7 over, and if you need to think about it this way, you can. It's the square root of 7 times 7. That's fine. Just know, no matter what, this is going to come out because it's going to couple out. And we're trying to do that. That's the whole purpose of rationalizing, because you get 4 square root of 7 over 7. 4 and 7 do not simplify. Those are both on the outside. Do not try to one these two out. That's not a thing. This one is protected by its radical. This one doesn't have one. They don't belong together. This is your final answer. Again, these are going to be a whole lot easier to write in something like Go Formative, etc. And I'll make sure to assess that for you. Or if you have multiple choice, you'll be able to find it that way as well. Here's the next one. Okay, this one, I've simplified some problem and I've gotten this. Well, I can't leave that denominator at the bottom, so I'm going to multiply both by the square root of 2. I know at the bottom it's going to be 2 because these radicals will cancel out. This becomes an outside times outside and an inside times inside kind of situation. Again, both prime numbers, it didn't really give us anything different. And 6 can only be done to this. And there are no couples. But we are not done with this, because you might see it is that 4 and that 2. 4 divided by 2. If you were to just cover this up, it would just be 2 over 1. Or in other words, 2. And you carry that square root of 6 right with it. And this would be your final answer. All right, thanks for watching.